Let's keep on going. Remember, definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. A derivative is a limit. So what does that mean? A lot of those limit rules we used will be applied to derivatives because derivatives are limits. We already learned that the derivative of a constant times a function is the constant times the derivative of a function, which is the same thing as the limit is a constant times a function, is the constant times the limit of the function. Well, those same rules apply for addition and subtraction. We had the limit of the sum of two functions was the sum of the limits of the two functions. Likewise, the limit of the difference being subtraction, the limit of the difference of two functions is the difference of the limit of the two functions. In other words, you could separate it and find the limit of each piece and then add or subtract them. Well, the beauty is, same thing with derivatives. If you want to find the derivative of the sum, it is the sum of the derivatives. If you want to find the derivative of the difference, it's the difference of the derivatives. So if you have multiple pieces, multiple terms here separated with addition and subtraction, just find the derivative of each individual piece and then add or subtract them together. This allows us to take the derivative now of instead of just something, a single term like x squared, we can now find the derivative of a polynomial like x squared plus 2x minus 3, because we could find the derivative of each individual part. So let's use these rules in the next one. It says find the derivatives. A is f of x equals 3x squared plus 5x minus 3. If I want to find the derivative of that, what do? I find the derivative of each part. What's the derivative of 3x squared? Well, it would be 3 times the derivative of x squared. Derivative of x squared is 2x. Plus 5 times the derivative of x. Well, the derivative of x is just 1. And then if you remember, what's the derivative of negative 3? Negative 3 is a constant. The derivative of a constant is 0. So you could have done plus or minus 0. It doesn't really matter there. So what do we have when we simplify? 3 times 2x is 6x. 5 times 1 is 5. The final answer would be 6x plus 5. Again, I want you to step back and realize the beauty of what we just did. If we had to do a limit definition of this problem, this would have been a very long problem. Lots of step, lots of foiling, simplifying, factoring out h. Just a huge pain in the butt if we had to do the limit process. We were able to find the derivative now in a matter of seconds and 2 lines. Appreciate the rules, learn the rules, use the rules. Make sure you show this step of work. The 3 times the 2x plus the 5 times 1 plus the 0, that's showing me you are using the addition and subtraction rule here, okay? The sum and difference rule is what they're called. You have to show at least one step of work for every single answer, so this step is absolutely required. Yes, later on in the semester we will skip this because this answer is, the 6x plus 5 is only a small part of the answer. So as we have more work to show, we can stop showing these small steps. But as for right now, since that's the only thing we're doing, you have to show that one step of work. Okay, so g of t equals 3 times the square root of t minus 2 over t cubed. Wonderful test question here. Really gets me, can you handle radicals and can you handle fractions all in one problem? So this is an excellent test problem. So what I'm going to do is I'm going to write g of t and I'm going to change this to the format that we would actually use. This should be 3 times, well, the square root of t, we know we need to convert to exponential form, so that would be 3t to the 2/2. Minus 2 over t cubed, we know we need to move that 2, or that t cubed up top, so that would be minus 2t to the negative 3. Again, you're going to get comfortable with this with extra practice, so make sure you concentrate on your homework. So now if I want to find the derivative, notice I am not writing just an equal sign. I have to write g prime of t because I am differentiating now. The derivative of 3t to the 1/2 would be keep the constant, drop the power, raise it to the power minus 1. So that would be 3 times 1/2 t to the negative 1/2. Keep the constant, minus 2, drop the power, negative 3. T to the power minus 1 would be negative 4. Let's do some simplification. Again, I'm going to go ahead and start doing 2 steps in one. 3 times 1/2 would be 3/2. T to the negative 1/2 would mean throw it into the denominator. makes it positive, and then I'm also going to change it to a radical. I'm going to do that both in one step here. So this would be 3 over 2 t to the 1/2, which is the square root of t. The next one, negative 2 times negative 3 would be plus 6. The t to the negative 4th, we have to bring just the t to the bottom, so it would be over t to the positive 4. If you try doing this on WebAssign, you might see a little bit of a different answer on your computer software program. What they might do is they might try to get a common denominator. I am not about that. I'm about keeping it as simple as possible, so this would be the answer for the derivative to me. But if you did see something different in WebAssign or any computer software that you're using for this, most likely they just got a common denominator and combined it to a single fraction. Not necessary for my class at all. Let's look at C here. C, again, excellent, excellent, excellent test problem here. Can't express that enough. Something like this will be on the test. What I'm looking for is, do you realize when you have fractions, do you actually have fractions? We do not know the quotient rule yet. What's the quotient rule? Quotient rule is low d high minus high d low over what's below squared. You don't need to worry about that yet. That's in another section to come. What you need to realize is if it's not necessarily having to be a fraction, don't make it a fraction. When does this work? This is always going to work when there's a single term on the bottom. When there's a single term on the bottom. Okay. If you have a single term on bottom, separate and simplify. If you have a single term on bottom, separate and simplify. So what do I mean by separate and simplify? Well, we did this in the algebra review. One way of doing this is by separating each term. Let me kind of brush up your memory again. So if this was 2/3 plus 5/3, what you would do is say, because they have a common denominator, that would be 2 plus 5 all over 3, right? So usually you're used to combining fractions. What we're doing on this problem is separating the fractions. We have it where it's combined and we want to separate it. Okay, so that's what we're doing on this problem. So this would be the same thing as x cubed plus 5x minus 1 all over x is the same thing as x cubed over x plus 5x over x minus 1 over x. That's separating. Now we need to simplify each of those terms. Notice, what is x cubed over x? Well, that's really x squared, isn't it? What's 5x over x? Well, that's really just 5. And then 1 over x, I really want to look at that as x to the negative 1, don't I? So my original function is the exact same thing as x squared plus 5 plus, sorry, I shouldn't say plus, I need to say minus x to the negative 1. That is my original function. X cubed plus 5x minus 1 all over x is the exact same thing as x squared plus 5 minus x to the negative 1. I have done absolutely no calculus to this point. Now I want to do the calculus. Now I want to find the derivative. So all I have to do is find the derivative of each one of those terms individually. The derivative of x squared is 2x to the 1, which is just 2x. The derivative of 5 is 0. And the derivative of x to the negative 1, so this would be minus, the derivative of x to the negative 1 would be negative 1x to the, well, negative 1 minus 1 is negative 2. Let's be careful here and clean it up. So we have a 2x, I'm not going to write the 0. Then we have a minus negative 1 is the same thing as plus. We have an x to the negative 2, so I need to throw it into the denominator. So that would be 1 over x to the positive 2. The final answer, my derivative would be 2x plus 1 over x squared. So, again, what's the strategy? When you see a fraction, you have to ask yourself, does it need to be a fraction? If there's a single term on bottom, almost always, you want to try to separate and simplify each of those terms first before finding the derivative. Let's move on. Here's another problem. Man, this page is just full of test problems. One of the questions that's going to be on virtually every single test this semester will be find the equation of the tangent line. And I remind you time and time again about this problem because that is what we're doing. That is what a derivative is. Before, you were able to find the secant line, the equation of the line through 2 points. Calculus gives us the ability to find the equation of the line at 1 point. So the beauty of calculus is now doing a more advanced thing, finding a rate of change at a single point. So this problem is the foundation of why we care about calculus. It'll be on every single one of our tests. So how do you find the equation of a tangent line? Well, if you remember, there's 3 steps. Find the slope. In this case, it's f prime of x at x equals, well, in this case, look at the problem, it's when x equals 2. So how do you find the slope? You find the derivative at the given x value. Second thing you do is you find the point. The point might be given to you. If the point's not given to you, the x value has to be given to you. All you do is plug in x to find the y. Okay? Then the third thing you're going to do is find the equation of the line using the point-slope form. That's the y minus y1 equals m times x minus x1. And then you solve for y. So that's how you find the equation of a tangent line. You did it in your algebra review, your line and functions review. You did it in the limit section already in the previous section. You're doing it again now, and it's guaranteed to be on this test and virtually every test from here on out. You've got to be comfortable with this. But here's the beauty of this. We did a problem almost identical to this in the previous section where we had to use the limit definition of a derivative. Now, if you read the question, same question, essentially, but it doesn't say using the definition of a derivative. If it doesn't say using the definition of the derivative, there's no way I'm going to. If it says using the definition of derivative, you have to do it with the limit process. This one doesn't. So let's look at number 1, finding the slope of the line. To find the slope of the line, I need to know the derivative. What's the derivative of negative x squared? Well, that would be negative. The derivative of x squared would be 2x to the 1, which is just 2x. What's the derivative of 3x? Well, that would be 3 times the derivative of x, which is just 1, minus the derivative of 2. The derivative of any constant is 0. Simplifying, we would have minus 2x plus 3. So the derivative, which is the slope of the tangent line, is negative 2x plus 3 for any given x value. Well, what do we care about? We care about when x equals 2. So when x equals 2, what would I have? The derivative evaluated at 2 would be negative 2 times 2 plus 3. That's negative 4 plus 3, that's negative 1. So what were we able to just find? We were able to find the slope of our graph. Step 2 was to find the point. How do you find the point? Well, you plug 2, the given x value, into the original function, not the derivative, into the original function. So that would be negative 2 squared plus 3 times 2 minus 2. Can't emphasize enough, please use your calculator. Make sure you're using parentheses in the proper place here, or you're going to mess up that negative. 2 squared is 4, so that's negative 4. Negative 4 plus 6 would be 2. 2 minus 2 would be 0. So it seems to me f of 2 is 0 would tell me that my point is the x value was 2, the y value was 0. There's my point. So now I know my slope and I know my point. What do? I go on to step 3, which would be the y minus y1 equals m times x minus x1. Point slope of the line. Well, in this case, it would be y minus our y value. Well, the y value is 0, right? M is negative 1 times x minus our x value. Well, that's 2. We need to distribute that negative 1 to both of those terms. Y minus 0 is just y. And on this one, we'd have negative 1 times x, which is negative x. And then negative 1 times negative 2 would be a positive 2. So what were we able to do? We were able to find the equation of the tangent line of the graph f of x equals negative x squared plus 3x minus 2 when x equals 2. We got the answer to be y equals negative x plus 2. What in the heck did we just do? Take a step back. I want you to go again to Desmos, D-E-S-M-O-S, desmos.com, or use that Desmos app if you downloaded it already, which I hope you did. But what I want you to do is I want you to graph this original function, and I want you to graph the derivative of the function. I want to see what you see, and hopefully you're seeing something like this. Here's the graph of negative x squared plus 3x minus 2. This is a total rough graph. I don't know where it shifted left or right, up or down, but something like this right here. And you're looking at when x equals 2, we have found the equation of the tangent line right here. So this would be the graph of y equals negative x squared plus 3x minus 2. And this would be the graph of y equals negative x plus 2, where the slope of the black graph is the same as the slope of the blue graph at that point 2, 0. At that point 2, 0. So that's what you're looking for. That's not an exact picture. That's just a big picture idea of what the heck did we just do. We just found the equation of that blue graph. That's what we did.